Now, the first thing that we're going to want to do with this is we need to get this integer value. So the selecting of the cell is going to take some user input. So let me just jump over to the main graph. We'll double click to select the root of the graph, and we'll take a look at this select texture input parameter. So this input parameter you can see is a type integer 1, and it's utilizing a slider. So here you can see the default value is 1, so we're going to start with the first cell. The minimum value is 1, meaning that it can never go below 0. And then the maximum value, in my case, I just set it to 27 because when I'm kind of working with these texture sheets, I never really envisioned myself doing more than 27 different cells within this, or dividing this up into a tile of 27 or anything like that. So I just arbitrarily chose 27 with this. And like I said, the important part is that the type of this is an integer 1, meaning that it's always going to be a whole value, a whole number value. We're never going to select cell 2.457 or something like that. It's always going to be cell 2, 3, 4, and so on. And the identifier name here you can see is set to selector. Okay, so let's jump back over to our pixel function and let's start to put this guy together. So the first thing I'm going to do is I'm going to hit the space bar and I'm going to get that variable. So I'm going to go to get integer and I'm going to use my drop down here, and you can see selector is already available to me, so we have selector. Like I said, this is an integer. It's always going to be whole number. However, the operations that we're going to do, we need to cast this to a float, just as we have been doing in some of these previous operations. So I have this node selected. I'll hit the space bar. I'll go to cast and I'll say to float. Because this is just a single integer, we want to cast it to a single float. Okay, so now that we actually have this in place, this is where we need to determine what cell we select. And to do this, we're going to use just a little bit of logic. So we need to compare this value here, what the user selects, by the information that we've been computing thus far. So when we take a look at this, you can see that we have derived a bit of information. We've taken the grid size, and then from that we have established a cell coordinate, and then from this cell coordinate we are able to derive an actual cell number. Now this is all taking place for each pixel in the image. Now at this point you can see that, like I said, we're utilizing this position variable, which again holds the pixel coordinates here that is given to us by the Substance engine. So when the node computes, the pixel processor node is being computed, the Substance engine is feeding back to us information for each pixel in that particular process. And then we're utilizing this equation here to derive the cell number. So when we take a look at what we have, for each pixel in the image, this graph is being computed for each pixel, which means we are deriving a cell number for each pixel. Now, the confusing part about this at this point is probably going to be that I say that we are evaluating the pixels for the image. I'm not talking about the image that we see here. So if we come out, we're not talking about this image yet, because this position, it's so far in this graph, we haven't dealt with any of the pixels from the image that are being fed into this pixel processor. So see how we have this connection, this image input 0? We're not dealing with any of this yet. So if I came in and I just kind of delete this and then we view the pixel processor has its own pixel information at this point. It's just like any other node. See here you can see that because it's set to parent times 1 in my resolution, the pixel processor right now is set to 1024 by 1024 because that's what my graph is set at this time. We're talking about the pixels here that are running for this particular image that we have. We're not discussing the pixels in this image at this time. So when we take a look at the pixel processor, we can see that the pixel processor, as I said before, will take a look and it will grab the pixel for the image. In our case, this is what the image looks like now. So it's running through and grabbing all this information. Even though we don't actually have like color information in these pixels, we're still able to denote, we're still able to break this information because we're only talking about values at this point. Like our grid size 3 by 3, we're using that to compute the cell coordinate. We're using that to compute the cell number. And so we're getting a value based of this. And again, like I said, for each pixel that makes up this 1024 by 1024 image, here it is, 1024 by 1024, for each pixel that makes this up, we are then grabbing that pixel and then computing this graph. Grabbing the next pixel, computing the graph. Grabbing the next pixel, computing the graph, and so on. And here, let me go back and just make this connection again here, and then we'll go back to our function graph. Okay, so like I said though, we're deriving this cell.x information for each one of these pixels. All right, and so we have this information, and then we also have the information for the cell that we want to select here. So what we're going to do, and actually the way I have this comment here, that can be just a little confusing. So let me do this. Let me grab this. So plus cell.x. Let's do this. Let's equals cell number. Because I don't want you to think here that I'm actually going to do this comparison here with cell.x. I'm doing it with the cell number. So again, we have the cell.y minus 1 times grid.y plus cell.x equals the cell number. So this value right here is going to be a cell number. Okay, for each pixel, remember in that image, which in our case, again, just to be clear, we're not talking about this image. We're talking about the image of the pixel processor node itself. Okay, so we're going to do a comparison to this. So here what I'm going to do is I'm going to hit the space bar. I'm going to go to comparison. I'm going to check to see if this is equal. So I'm going to take this value here for our cell number, and I'm going to put this in here into the input A. So I'm basically saying, okay, for the computed cell number, again, which is happening per pixel, okay, in this image, so we're checking each pixel and we're computing a cell number. If whatever pixel the pixel processor node is computing at that time or evaluating at that time, if that cell number that we're deriving using our operations that we've hooked together, whatever that cell number is, if it's equal to the cell number, okay, which again, this is our selector, the cell number that the user is selecting, so we're going to put this into B. So now we're saying if that's equal to, let's move it like this so we can see this a little bit more clearly. So if this computed cell number is equal to, this is the equal, to whatever the user has selected, and again, remember it's going to be a whole number, 1, 2, 3, 4, and so on. If those things are equal, then we need to do one operation, and if they're not equal, then we need to perform another operation. So the way that we do this, one operation or another, we're kind of asking that question. If this is true, then do this, else do this. That's an if-else statement, and we can do that here within Substance Designer. So I'm going to hit the space bar, and I'm going to come over here to my control, and I'm going to grab this if-else sequence. And so notice here that the inputs are white. So this is a white output and a white condition input. White meaning that it's a condition. So these guys are color coded here. So these are, you can see that green here we're working with float. Yellow here we're working with integer. White is a condition. Blue, we really haven't set it with any value yet. So as soon as I take this and set this condition in, you can see that right now we now have the ability to do this if or this else statement here. Okay, so what we want to do is we want to start to feed in some information. So what this says is if this is true, if this condition is true, then this node is going to output whatever values are in this first input. If it's false, it's going to output whatever values we hook into this else input. Okay, and now again, here is our output. All right, so what are we going to put within these values? Well, the way this works, and it's kind of nice that we kind of see it like this now. The reason why that we are is because of the way if we go into our graph. Let me just zoom out. Again, remember, we already have this graph here is computed. And this is, node is set to yellow, meaning that it's the output node. I'll show you what I mean by that in just a moment. So that's how we're viewing this node, and I'm actually just double-click, and I'm viewing that pixel processor here into the 2D view. So let's just come down here and take a look. All right, so, well, I'll tell you what, let's do this. In this case, you can see that this was equal. So here we have this statement here, just like we have below. All right, and if it's true, we're doing this information, which we'll cover in a second. And if it's not true, then we're going to give it this piece of information. So you can see if something's true, what we want to do is we want to sample some actual pixels in the image that we're feeding into the pixel processor node. Okay, and we want to show those pixels. And if it's not true, okay, then meaning that the cell number, the computed cell number, and the cell number the user has chosen, if those two numbers don't line up, then we basically don't want to show anything. We want it to be completely transparent. And so the way that we do that is for the false or the not true is we're going to hit the space bar here, and I'm going to go into a constant, and I'm going to make a constant float 4. Okay, and I'm going to feed this guy in. Now notice this is green for float, and I'm going to plug this guy in. Notice as soon as I plug this in, all of my inputs and outputs all become green. This means that I can't mix and match these data types. It has to be green. And that shows you why we were casting a lot of this stuff to float. Okay, now the reason why we're using float 2 because we're dealing with RGBA color. The way Substance Designer works with color is it needs RGBA. So there are some options in your color, like for instance, just to show you what I mean by this, if we hit the space bar and I go to say something like a uniform color here, notice here that we have values for a uniform color. So if I just pick a color to this guy, we've got R, G, B, and A. And if we look at all these values, so each one of these values is a float value. So right now we're looking at this like an integer in the slider, and this is just kind of the UI, but behind the scenes we're looking at these values as like a float. And in order for this to compute a color, we need to tell the Substance engine that this is a float 1 is red, float 2 is green, float 3 is blue, and float 4 is alpha information. So it's a float 4. So now if we come back over here to our per pixel function, we have a float 4, and notice here that we're just giving this all these values, so 0, 0, 0, and then 0 for the alpha. The only thing that really matters is we can put any values we want here. Negative, none of this stuff really does anything. It won't hurt anything. We can actually just leave this at 0. This is what really matters. So this 0 alpha, you can see that because I fed this a transparent image, this is the way that I'm going to work with these decals, because I would then layer these guys, these stamps or these decals or these logos, I would layer those on top of another texture. So I would feed this, a transparent image, and so this alpha needs to be 0. So for instance, if I come up here to the top, we know that this part of the graph is already working. If I go to this float 4 and I just start to feed in some information here, you can see it's not doing anything. It doesn't hurt it. What does hurt it is when I start to introduce this alpha. So as soon as I start to pull this alpha in, now that we have alpha, you can see where this color value is actually taking place. So if we move this all the way to 1, 1, 1, you see that we would have white. And if we move it all the way to black here, 0, 0, 0, we get black. But you can see here where this really matters, okay, where we just have this alpha information. So as soon as we set this here to 0, this is where we're getting that alpha. All right, so what we want to do is say that, okay, if the computed cell number is not equal to whatever the user has selected in that input parameter, then we need to make sure that the pixels are completely transparent. The alpha is set to 0 because we don't want to see them. Now, if it is true, what we need to do is we need to go and get the pixels in this image, and we need to replace that cell that we've computed. Okay, that cell that we've computed, that cell number that we computed, we need to replace that cell with pixels from the image that we're feeding the pixel processor. So notice here I have this image, and I'm feeding this here into the image input 0 here of my pixel processor node. So in order to do this, what we're going to do is I'm going to hit the space bar, and I'm going to get a float. So here I'm going to say constant, or actually I'm sorry, variables, get float 2. And now I want to go back to my position variable again, because we want to do this on a per pixel operation again. So for each pixel in this image now, for each one of these pixels in this image, we're going to replace it. So now I need to sample this value. Okay, so to sample this using this position value here, which again is going to be per pixel, I need to hit the space bar and I need to go to my samplers and I do a sample color. So I take this, it's asking for some position information. My position information is here, and again that's coming from the Substance engine, that position system variable, and I plug this in. Now when I have this node selected, you can see that I have a drop down here for my input image. Okay, so I have input image 0. I don't have any other inputs selected here. If I did, let's say that I came over here to this graph, and let's just say I took this image, or here, let's grab this uniform color and I feed it here into this input image 1. Okay, now I have another image input has been given to me. So now if I come back to the sample color and I drop this down, you can see that I can choose which one of these images I want to sample here. So in my case, I want to work with input image 0 because that is the actual image that I have input. So let's just take this connection and disable it for now. So we'll go back to this guy. So now I'm going to take this and I'm going to feed this here into the if statement. Okay, so what we have here is our completed conditional statement. So here I'm going to come in and I'm going to say, okay, for this computed cell number, and we've talked about how we were getting that computed cell number. If that computed cell number is equal to the number that the user selected, so here that's going to be the number that the user selected here in using the select texture. So by default it's going to be 1, meaning cell 1. If that's true, so here's our if-else statement. If that's true, that means we're going to output this first node. All right, and so it is true. We've selected the 1, okay, by the input, All right, and if that's true, then we're going to get the position of that pixel, okay, and we're going to sample that information, that position, from this input image, and whatever those values are. So for that first cell, what we're going to do is it's for each one of these pixels here. So it's going to sample all these pixels like this as it kind of moves across this row. And as you can see, almost like a dot matrix printer here, it's building these pixels here row by row until we get this entire cell processed for us. Okay, and then we're going to set this here into this value. We're going to output this. If it's false, meaning it's not, so it's going to be, in our case, by default, it's that first cell. So all these other cells are now going to get the color of, well, in our case, let's just set it to 0 here. We'll do this 0, just clear everything out. So it's going to be, red, green, blue, 0, and alpha 0. So all these other cells are going to equal 0. So if I take this node here and I just right-click and I set this to output node, okay, so now we have this set to output node. Let's go back to our main graph and let's double-click our pixel processor to output that. So now you can see that our operation is now taking place. Okay, now if we go back to our cell, we'll double-click. Let's go. Let's just turn this into preview mode. Let's select our second cell. So now we select our second cell. So what happens is the position information is now gathered first. So here's our position information. Then the entire graph is computed per pixel for each pixel in the image. Okay, so the first thing is the grid size is computed. Then we do these nodes here. That's going to get us a cell coordinate here. So it's going to use that position value multiplied by the grid.x and y to get a cell position. Then we're going to use our equation here of cell.y minus 1 times grid.y plus cell.x to equal a cell number. Okay, so this is what I'm calling the computed cell number. Once we have that, we're going to check to see if that cell number is equal to whatever the user selected. So in this case, in this slice that we're kind of looking at right now, we selected cell 2. So this computed cell number, okay, remember it's just doing it for every single one of these pixels in this image. This cell number is equal to the second cell in this particular case because it's showing the second cell. So what happens is we get the position of each one of these pixels that are in the area of that cell. We sample that color, okay, again, that sampled color that's coming from this area right here in our image, and then we output that. Now, for everything that's outside of that cell region, we're just simply taking the float and just 0, 0, 0, 0, 0. Okay, if we were to pull this all the way up to 1, this is what it would look like here. So that's what we're doing. Okay, so when we take a look at this portion right here, you can see that we're getting the position for all of these pixels here. Let's zoom in. All of these pixels, even the transparent ones, all these pixels. So we go, row by row, like I said, like a dot matrix printer here, as we just kind of scan through this cell, and we're basically, sampling the pixels that are in that image, and we're just revealing them, so to speak. I mean, really, that's what we're doing. We're just kind of revealing them. And then, for all the other cells, we're just setting them to 0 so we don't see them. And that is how we're able to take this function here, and that's how we're able to process that. So you can see that we didn't actually process any actual pixel information until the very end, where we just sampled the position value here. Up to this point, we have been discussing our position variable, the system variable that represents the pixel coordinates, and we have been using 2 copies of this. So here we have a copy where we have been utilizing getFloat to grab hold of the position system variable, and we're using that here to compute our cell coordinate. And then we're also using another version of it here as we get the position data, as we get the pixel coordinates that we're going to sample here using our sample color node and the image input 0. Now, we don't actually need 2 of these nodes. The reason why we have 2 thus far is that it makes for a more simpler explanation, and it lets us read the graph a bit more clearly. But if I were to come into this node and just delete it, and I could actually grab this original variable that references our position system variable, I can actually just plug this same node here into my sample color, and you can see that everything works correctly. So I want to clarify that you don't have to have multiple versions of this position variable in your graph. You can actually just use the same one. And I also want to be clear that this position node, even though that we had 2, they weren't taking place independently of each other. They were both doing the same operation. However, having two of the nodes here just let us kind of break the graph into, like, two sections, and you can see here that, extending this connection all the way across our graph makes it a little bit hard to read. So if you want to, if you're going to be using this position node or getting that pixel coordinate data, and you have a very large graph, and you don't want to have, connections going all over the place, it is okay to use multiple copies of that. However, know that that pixel coordinate information is only gathered the one time that you see here. Now, let me show you what I meant about how this is going to kind of be broken now. So if we come over here to our select texture and I start to just move through this, you can see it works. So there's 9, but if I go to 10, there isn't a 10. So it's just invisible. So this isn't really broken. You just know that this doesn't work or whatever. But, the next part of this is that we're going to show how you can just kind of loop through. So when we get to 10, instead of it being just nothing here, we can actually force it to go back to cell 1. Okay, so here we are back in our function graph, and we're going to implement this looping mechanism. Now, to do this, we're going to rely on some modular math, and we're going to use the modulo operator. So if I hit the space bar and I go to my operators, I have this modulo operator. Now, this modulo operator is oftentimes abbreviated as a mod. And we have two inputs. So here we have a divisor, and this first input, A, is going to be the dividend. So this mod operation will find the remainder after the division of one number by another. Where this becomes useful for us is that we can use this mod to create a repeating sequence of numbers. So when we increment numbers by 1, which is what we're doing with our selector input parameter, and then divide them by our grid size, the remainder will start at 1 because our selector control starts at 1, and will increase by 1 each time until the number reaches 1 less than the number we are dividing by, at which point the number sequence repeats. So here I have my calculator with the history available so that we can see exactly, how these numbers are incrementing. So here the first operation I have is 1 mod 9. And so you can see that the remainder here is going to be 1. Now if we go to 2 mod 9, you can see the remainder value for this is going to be 2. 3 mod 9, we get 3. 4 mod 9, we get 4, and so on as we start to just move through the sequence. So for instance, here we have 8 mod 9 and we get 8. Now when I move to 9 mod 9, you can notice here that we get this case where the remainder now becomes 0. Now this is going to cause us some problems, and we're going to have to work through this. It's not a big deal, but we'll work through this here in our function. But what I really want to show is what happens when we do 10 mod 9. So here when we do 10 mod 9, notice here now that our sequence repeats and it starts back at 1. So now we have 11 mod 9, 2, and here if we go down, well, 11 mod 9 is all that I have. So here you can see where the numbers are repeating here. So we go from 0, 1, and then 2. And so what happens is when our input slider then becomes out of range of what our grid size is, so in our case we showed 10, and currently this is what we get when we have 10. We can't see any of the cells visible because what we have here in our function graph at this point is that they're no longer equal, so we're just outputting the value that we have here, which is 0, 0, 0. But now you can see using this mod operator is that we can use this to set this integer value. So now you can see that we can use a mod of our input parameter and our grid size to repeat this sequence. So at 10 mod 9, that will bring us back here to cell 1, and then we can just show cell 1 as we've been doing here. So now let's go ahead and just start to set this up. So we already have our mod in place, and let's start to set up our grid size multiplication. So we need to get that divisor number, and that's going to be our grid size x times our grid size y. So here I'm going to hit my space bar, I'm going to go to my operators and go to multiplication. And let's just zoom out here and let's grab our grid.x and we'll plug this guy into A, and our grid.y, and we'll plug this into B. So now we have this multiplication, and so like I said, this is going to become the divisor, so we'll plug this in. And so here again we have, this is where we're getting the integer of our input parameter for our selector, and so we've already casted this to float. So let's take this guy, and this is going to become the dividend. So let's take the output and plug this into mod A here. And so now that we have this in place, what we could do, let's just make some more room, move some of these nodes out of the way, is that we can go ahead and take the output of this mod operation and just feed this here into the equal B input. So when I do this, you can see that we now get our value back here. So let's go back to our main graph. Let's double click to get to the root graph. Let's go over and preview our actual operation. So now you can see that we're at 10, and we're using that mod operation. As we saw, 10 mod 9 gives us 1, so now we're selecting the first cell again. And if we go back to 11, here you can see that we're at the second cell, and so on, just as you saw in the calculator example. However, the problem that we get is if we take this to 9, you can see that 9 mod 9 is 0, so we don't see anything. But if we go back to 8, so 8 mod 9 is going to put us into the correct cell. So what we need to do is figure out a way to fix or bypass this issue where that mod calculation is going to return 0. So let's jump back over to our pixel function and take care of that. So it's actually going to be pretty simple. We're just going to check to see if the output of our mod is going to be 0 or not. And if it is, we're just going to use a different value other than the value from the mod. So let's do this. Let's just hit our space bar here, and let's go to our control, and let's grab an if-else. Now we need a condition, so what we want to do is do a comparison, and we want to see if something is equal to 0 or not. So what we're going to do is take the mod operation, we're going to put this into A, and we just want to check to see if this is equal to 0. So I'm just going to go to this constant float, and float's already at 0, so this is going to be good. I'll just put this into place. So here we're checking to see if our mod operation is ever equal to 0, and this is going to become our condition. So when we take the output of this equal and put this here into our condition, we're now asking the question, is this mod equal to 0? If it is equal to 0, then we're going to output this if value here that we're going to supply in this first input, and if it's not equal to 0, we're going to output the else value that we're going to place into the else input. Okay, so if it's equal to 0, what we want to do is we just want to supply the actual grid size itself. So that's going to be the grid.x times the grid.y, and we already have that here in this multiplication. So let's just take this output and plug this here into the if. And if it's not equal to 0, then we just want to grab the actual mod itself, the value from the mod. So let's just grab the output of this and plug this into the else. So now we have this little bit of conditional logic that's going to help us to check if it's equal to 0, and if it is, we're just going to kind of bypass the mod value and pass on our value for our grid size multiply. So again, the grid size.x and y multiply. So now that we have this, let's just go up to our equal here. We're going to take the output of this if-else statement, and we're just going to replace what we had before with that mod. So we'll put this into place. Now as soon as I do that, you can see that we now get our value back. So we're good to go. So here we'll take these nodes here, we'll select and just kind of move these guys out of the way. So here I'm just kind of organizing this, and then what we're going to do for this guy, this is going to be our select cell region here. So I'm just going to select all of these nodes, and I am going to add a frame to these guys as well. So here we have this selected, and I'll just call this I'll just call it cell select. And again, if we go back to our main graph, I'll just double click here to get to my input parameters, and I'll preview this. So here we can see that 9 is working. If we go to 10, that still works now. It takes us back to that first cell, and so on. So if I just move and loop through this, you can see that we get to 17, 18 works, and then if I go to 19, now it just repeats back and forth. So now we have this ability to select any number of these cells. If the cell number ever goes out of range, then we're just going to loop back to the very beginning again. So this is going to conclude our in-depth look at the pixel processor node within Substance Designer. As we've showcased, this node is extremely powerful. It can be used to filter images, to create any number of tools, and the main usage of it is going to be anytime that you need to process or evaluate a bitmap on the per pixel level. So I hope you've enjoyed this video, and I'll see you next time. Thank you.